I am Kodesh. This video is about to know the how the Opus codec performs in order to analyze the performance of the Opus codec. These are the files that I'm going to use in order to analyze the performance of the Opus codec. You can be able to see here the Opus ANC, Opus GCE. These two are the actual files which encodes and decodes the data that we are going to give. The data that I am going to give is this file. It is an audio file which is in the format of WAV. Let's see what the data that I am going to give. I am Kodesh. I am going to record the audio in order to analyze the performance of the Opus codec, and I am involving the some of the music. This music helps me to analyze the exact performance of the Opus with a different sampling rate. Let's check how it works. Here in the audio data, I had also involved the music in order to easily analyze the performance. You can be able to easily predict how it works the encoding. Uh, let process for the encoding and decoding operation. This is the command line prompt where I am going to give the instruction for the encoding, that is opus enc. The file name that I am going to use verify, which is in the format of WAV, and I'm interested to convert it into the file name of output one dot. It need to be in the format of opus, so I'm giving opus. See here, encoding completed. Actual input of the bandwidth of 44.1 kilohertz, and defaultly it converted with the help of the sampling rate of 64 kilobits per second, where this is the actual analyze encoded data of 25.86 seconds, and the bitrate that it used is 72.6438 kilobit per second, and the instant rates where you can be able to see is from 44.6 to 132.8 kilobits per second with the overhead of percentage in the packet of 1.24%. See with this can be able to see this output. This is the output one where I have encoded the actual information. So you can be able to see it is a opus file where WAV file get converted to the opus file. Now I also decode it. In order to decode, the instruction is opus dec. The file that I am going to decode is output one dot, which is in the format of opus. I'm going to convert it into the input one dot WAV, where can be see here it defaultly taken 64 kilobits per second. So right, so I rename it to 164, indicates 64 kilobits per second. Okay, I done some of the mistake. Yes, I have written the name error. Opsu deck. It is not Opsu deck. It is Opus deck. Let's see. Okay, decoded completed. Let's check. See, you can be able to get the input which is in the format of WAV file. From the actual verify information of WAV file get converted encoded to the Opus file and then decoded to WAV file. Let's listen the what the output that we get at the 64 kilobits per second. I am Kodesh. I am going to record the audio in order to analyze the performance of the Opus codec, and I am involving the some of the music. This music helps me to here you can it seems to be like actual information, but when you observe that very deeply there is a little variation. Even the information that I have taken is not a such a type which contains different type of frequency. It just limited to certain levels. So it means it is a low level, very low frequency. So at the sampling rate of 64 kilobits per second, it covering the total information. So it seems to be like the actual information that we are given as an input. Even the opus file that we compressed, you can be able to see it is as a 233 kilobytes, which is actually 2227 kilobytes. After decoded, it converted into the 2227 kilobyte, which is the actual size of the information. Now we convert. Let try to sample with another sampling rate. Okay. Um, I'm going to give a bitrate of 5 kilobits per second. It is a verify.v actual input. Now I'm going to change this output to 5 kilobits, indicates 5. Okay, it converted. So you can be able to see here it has 5 kilobits per second, and the instant rates around 3.2 to 8.8 kilobits, and the actual bitrate that we get without the overhead is 4.90704. And now we decode it. Okay, but here the actual input that is not output 1, it is output to 5. To let's convert it to input to 5. Okay, opus deck failed to open. Fail to open, can be able to see here fail to open output 1 or 5. Output 1 5. Let's see whether it get created or not here. Yes, it is output to 5, so I give an error, that is output to 5, but here I have entered as output 1 5. Output to 5 to input to 5. Okay, it converted. See here, output to 5 is created, input to 5 is created. Let's see how the even it is the size of actual information, 2227 kilobytes. Let's see how it looks.
Kodesh. I'm going to record the audio in order to analyze the performance of the Opus codec involving some of the music. This music helps me to analyze the exact performance of the Opus with the different sampling rates. Let's check how it works.
See here, you can be able to easily analyze it in this case where the actual data is not transmitted. There is a we lost so much information because the sample rate that we are taking is very low, that is 5 kilobits per second. But in the previous case, it is 64 kilobits per second. This is the variation that we can be able to see. And now we try for another bits per second. Let's check for a bit rate of 30 kilobits per second. We take the actual data and we convert it to the output 3 30. Get converted, and we also decode it. It is the output 3 30 kilobits. I'm going to name it as input 330 so we can be able to easily recognize the data. It also decoded completed. See here, output 3 is encoded information, it get converted to the decoded. Let verify it.
Kodesh.
I'm going to record the audio in order to analyze the performance of the Opus codec, and I'm involving the some of the music. This music, yeah, for this case, it seems to be it looks somewhat more related to the actual information. We didn't lost a much of information as compared to the 5 kilobits per second. So by varying the data sample rate, we can analyze the quality of the audio because this change in audio it is due to the encoding. uh, while encoding we are going to lose so much information where you can be able to see the output one is a 64 kilobits means it had taken default is 64 kilobit. You can be able to see the size of it is 233 kilobyte and we observe the quality of it is very good. But when next we go to the 5 kilobits, we can see it's 19 kilobit of size. It is very low. Means we are lost so much of information. Because of this reason, at the output, it doesn't get the actual good quality of information. But in the case of 30 kilobits per second, it is 106 kilobits per kilobits per second. See how it varies. So, the data we collected at most and the quality also good. This is how the Opus codec works, where the encoding decoding takes in the very manner where encode tries to compress the data, and meanwhile can be able to adjust in different manner in which sample rate that we need, whether it is 5 kilobits or 10 or anything else. It can be able to operate from the range of 5 kilobits to the 510 kilobits per second. Okay, thank you.